You can use Azure App Service anytime you want to take an existing brownfield application, a web app, and move it to the cloud. The beautiful thing is when you move it, you don't have to bring the server with you. You're never going to have to set up another patch on your machine. You're never going to have to reboot that particular machine. We're going to take care of all that for you. And it doesn't matter if you're doing Node.js, Python, you're building a WAR file, or you're doing .NET. All those applications can run unmodified. And that's the key. We don't have to learn anything about Docker. We don't have to change our application in any way. The development is exactly the same. The code is exactly the same, but we're going to allow you to now take full advantage of the cloud. You can scale it up and you can scale it out at the click of a button. You're no longer held hostage to the infrastructure that you have on-prem, and you no longer have to baby or monitor those particular servers. I love it as a developer because I just focus on delivering value, and the rest of the entire infrastructure is handled for me.
Well, thank you, Donovan. I love those little intro videos. Like, we always get a kind of quick nugget of information about how we can use Azure. So anyhow, my name is Jay Gordon. It's right there on the bottom of the screen. We'll point to it. There you go. Welcome back to AzureFunBytes, which I can point to right there. It's been a few weeks, and that's because it's been a busy few weeks for Microsoft. The last 2 weeks we've had Ignite, and then after Ignite we had .NET Conf. There was a lot of really interesting stuff that came out of that, a lot of new services, a lot of new ways for you to work with Azure, or work with Microsoft technologies, and that has really inspired me to try using some of these things. And so we're back once again this week. We'll be gone next week because, you know, for us here in the States, we have Thanksgiving. I'm looking forward to having a giant meal with my wife and enjoying some of the downtime that comes with the Thursday, Friday weekend that gets extended into the regular weekend. So enough about what I've been up to. I want to talk to you this week about a technology that is tried, trusted, and true when it comes to development, either for the web or for other applications that we're all very familiar with. I feel like if you've gone ahead and worked in the world of the cloud, which is Java. And Java is a technology, it's been around since around like 1995. You know, you go way back in history to the very, very first releases. Where 95 was a huge time and for the development of software, because we started seeing this interest in having more and more connected software, things that had networking capabilities so that you could actually utilize these types of programs in large complex systems. And so Java came and provided this cross-platform independence that allowed you to have it extremely portable. And we're going to talk a lot about that today. We're going to get to know a little bit more about Java. And to help me do that is my man from South Africa, none other than Rory Returns. He's a senior cloud advocate with Microsoft. How you doing, Rory? Thanks for coming back again.
Thanks, Jay. It's always interesting, different, and interesting to be on your show. I never kind of know what you're going to ask. I've prepared everything possible, including the kitchen sink. So hopefully we can cover a lot today. If you don't know me, I am from Johannesburg, South Africa, which is as close as New York as you're ever going to get in Africa. I've got brown hair. I'm wearing a Microsoft Java and Azure shirt, and I'm 4'1". I've got achondroplasia, and I'm sitting here in my home office with my little streaming plants here, and I'm very, very excited to speak to you about Java on Azure.
Sure, and just to follow suit, I am Jay. I am a white male. I am wearing a black Brooklyn Nets cap backwards. I'm wearing a black Kiss, the band Kiss t-shirt, and behind me some nice blue lights. So this is who we are, and this is what we're going to be doing today. We're going to be talking about Java and figuring out how it works together with Azure in the best possible way. Before we get started and start diving in, Rory, I'm going to ask you a couple questions. But before that, I want to remind everybody, every time we do this show, we have a poll. And I'd love you to go and take the poll. So what infrastructure are you deploying your Java apps with? And we've got a couple options: virtual machines, which are, we all love our VMs, app service, which Donovan told us a little bit about before, functions. So we can go serverless. We don't have to worry about infrastructure at all. We just create our code and upload it. Kubernetes, if you want to go hog wild and really get into distributed complex systems. And then there's Spring Cloud. And Rory, I'm going to ask you a little bit about Spring Cloud today. I know that there's some new features that came out for it. And I just want to remind everybody, if you go to the Learn TV website, you can go and take the poll. So it's aka.ms/Learn TV. And if you're watching on any of the other native platforms, feel free to send your questions. We want to hear from you. It is always great to have our audience take part in these shows. And we've got a lot of different types of things to talk about today. Rory, you gave me a jam-packed agenda, just so much to kind of talk about. And so I'd love to kind of, start from the very beginning, which is, how did you take your first kind of jump into utilizing Java as, say, your primary language for developing software?
Thanks, Jay. So in the beginning, let me bring my brand new Rode NT-USB mic closer to me. So sensitive. In the beginning, I was actually an infrastructure person, and I started off, my first qualification I ever got was an MCSE, a Microsoft Certified Systems Engineer. And I started doing rack and stacking for large multinational banks. And they had, at these banks, they had software engineers, and they would come and they would give us a CD and give me a CD and put it into the hardware that I was managing. And I would be fascinated because they would put the CD in, they'd write something there. And suddenly now the system would be brought up and it would just start running. I started learning Java as part of my undergraduate degree at the same time as I was doing this infrastructure management. And I was smitten by it because the infrastructure that I could manage there, the databases, the server, I could speak to it on a machine level now. And I've never looked back. I've been a developer since 2001. And I started in the first version of Java 1, all the way back years in 1998. I wrote my first line of code, and I started professionally as a Java developer in 2001.
Wow. It's amazing to watch how many people I know who actually started off in infrastructure and from there decided to make that shift over to development. And I think a lot of it has to do with that. For most people who are involved in infrastructure, you need to have some sort of grounding in the kind of code you're working to support. I know that, like, I worked a long time in infrastructure and operations, and there were little things like using Red Hat kickstarts because I was, doing everything in Linux, and I would have to understand the language that all these files were written in so that we could actually do deploys, create what we needed to create. And a lot of people I know took that kind of idea of like, all right, well, I need to understand this anyway. Why don't I just start using it myself? Let me start tinkering, and tinkering turns into eventually gaining enough skill to say, I'm competent in this, and then going beyond just being competent and creating things that people want to use.
No, I completely agree with you. And it's the tinkering mindset. Developers like to break stuff. We're impatient. We have element of laziness, and we're arrogant. That's Programming in Perl, the book by Larry Hall, 1991. And I had all of those aspects, and I didn't want to do the rack and stacking if someone else was going to do it. I wanted to do both of it, so I could manage the hardware and also the software. And I eventually went into an architectural role, which you have to do that. And then finally, I found my true passion, which was developer relations. And then I could meet the developer where they are and help them and uplift and empower them to be able to really achieve great success using the Microsoft ecosystem. And here we are today, a Java developer working for Microsoft. I'm on a Mac and using the Chrome browser, and the world doesn't make sense anymore because it's not necessarily about what you use, but it's the empowerment and the companies that can help you, empower you to get from an idea to a production grade system.
Absolutely. So there's a lot of great documentation available that helps people start learning about how to use Java. And I think that this is one of the great things that you can go to. It is a learning path. It is on Learn. So you can go to aka.ms/learn. You get tons and tons of free training about Java on Azure. You'll get some demo code to use. You'll get some methodologies to deploy it. I think that you'll get a lot out of it if you go and take a look. But that's just the beginning of getting started. And so I'm curious about this, Rory, and I want to ask you this first question. How does a developer start with Microsoft Java tooling?
So we have more than 1 million Java Visual Studio Code users right now, and growing exponentially. So much so, we're actually nearly on the same level as our main competitor for the paid product that they have with their tooling. It's actually one of our partners. As a result, we have helped so many developers start with Java just from the Visual Studio Code ecosystem. And the easiest way to get started with Java with Microsoft is to download Visual Studio Code and to start with the Microsoft OpenJDK. So we're a full-fledged member of the Java community process. It's very similar to the .NET Foundation, whereas you can help grow Java through community-driven processes. And you also have, if you want to, have a distribution for the Microsoft OpenJDK. And we can customize the Microsoft OpenJDK to a degree to run really optimized on Azure. And we did that recently. We actually launched a OpenJDK version to run on ARM because we have a lot of products that require ARM Java to run on it. So as a result, we now can really help the community, and we published that edition, and it was really well accepted by the broad Java community. So start off, you download the coding pack for Java, the screen that you just put up there, and then that comes with everything you need to get started. It doesn't come with the Microsoft version of the OpenJDK. It comes with something called Adopt OpenJDK, which we're one of the founding members also. And when you download this, it's going to say, okay, do you have Visual Studio Code? If not, I'm going to install it. Do you have a JDK? If not, I'm going to install it. And once you do that, it's set up and you're ready to rumble with Java and Visual Studio Code. You can go further with that by installing the Azure Toolkit. So once you install the Azure Toolkit, then you can just right-click on your Java application, which I've got a really nice demo on how to get started with that. And you can just right-click on that and go deploy to Azure. And it's that simple to get started with Java, with Visual Studio Code, and with Azure.
So I know there's a Microsoft build of OpenJDK, which I think is one of the big things you wanted to talk about. And it's open source. It is available for everyone to download for free. And so how does this differ from, say, like the Oracle JDK or something like that?
So all OpenJDKs, including the Oracle OpenJDK, which they've actually put on GitHub. You know, the irony is like they've used our repository to actually store the Java OpenJDK, has to conform to a testing kit. And the testing kit goes in and scans and runs certain tests, like 5,000 of those tests against the OpenJDK to validate that it does conform to a standard. Now, Java is just standards driven. That when you say Java, it's a language, But that language and all of the libraries are all driven by standards. And those standards go all the way back to 1991 when they first created that tooling to be able to run anywhere and any time. And those standards have really been tested by time to say, if you adhere to the standard and you have an OpenJDK, the Oracle, the Red Hat, the Microsoft, if you are standards driven, then I can install yours or mine or anyone else's, and it will just work. Now, if I want to have a specialist one, then I can also. So, for example, there are some JDKs like one of our partners, Azure, which has no pause JDKs meant for embedded systems. So if you want to run a good JDK to run on a spaceship, then you want the no pause GC, because if it pauses, you don't want to be in that spaceship when it pauses. So
no.
So to answer your question, everything is kind of very similar, but there's a little bit of flavor that you can get when you go to different vendors. And ours is great for Azure. It's great for development. And we have a support agreement with it. And we support the LTS version of it, so 11 and 17. And we patch it, we auto-patch it, and we actually release it on a good cadence to make sure that our customers are well supported.
Sure. So now the next question I have is about this SDK. How does a developer start utilizing this SDK to build alongside Azure?
Thanks, Jay. So everything that you see on the Azure portal actually runs through the Azure Resource Manager, which in turn actually calls a REST service, which in turn actually calls the SDK. So you think about it, right at the bottom of the bundle there's some libraries that are running, that are processing every time you want to start up a VM, you want to deploy an app, or start up an app service or a Kubernetes cluster. And you can do everything via the Azure portal. But you can also get low-level control via the Azure SDK for all of those services. So if your VM might be battling because it has run out of resources or memory or CPU, you can actually bring up another VM in that scale set. And you can do that programmatically in Java. And all of these SDKs are usually available in all the major languages. So if you want to do it in C#, in JavaScript, in Python, in Java, all these SDKs allow you the ability to have full access to the Azure portal and the platform with programmatically being able to write code for it. And one of my favorite things that we've also added, and which really goes well with the Azure SDK, is that Microsoft has released Spring libraries. Now, these are called Spring Integration Starters. So when you have the Azure SDK, if you want to have a library that is programmatically similar to the Spring lifecycle, you can just embed one of these libraries into your Maven or your Gradle path, and it will pick up that library and connect to the Azure resources, very similar to dependency injection. So you have, a MySQL database. You don't have to code your code to be even aware that it is talking to a MySQL database. You use these Spring libraries, and then the power of the Azure SDK, you can go and go, wow, my logs are getting too big. I'm going to go and archive my logs programmatically and also use the Spring libraries for your program. So you get that low-level access control with the Azure SDK, and you get the programmatic lifecycle dependency libraries that we have that we support with the Spring integration libraries.
Very, very cool. And so I'll ask you a little bit more about what Spring Cloud is and how it works on Azure to, I guess, create a different hosting platform than just installing a JVM on a server and just going. But first and foremost, why does the Azure Cloud make application maintenance easier for users and developers?
So the seminal book that a lot of developers reference is called by Brooks, The Essential Difficulties of Software. And he said that in his book, with I think the title was No Silver Bullet. And he said that software is actually got 4 essential difficulties. I'm going to try and remember them off my memory. Number 1, it changes often. And change can create disruption. Number 2, it conforms to industry bureaucracy that we shouldn't have to conform to. Like compliance, you have to. Number 3, it is complex. Software and hardware and just IT is hardware. And number, I did get them all. The last one, it's invisible. Meaning that you don't know what it's doing on a good basis, like it's just there. So when you work in software, you want to create and you want to have a platform that actually mitigates a lot of those features. So if you have a Black Friday, which is coming up right now, and your infrastructure sparks, you want to be able to have auto-scaling features that allow you to actually spark with that. If you have invisible problems and you're not aware of your software, you want to have distributed tracing with application insights that allow you to actually go in and see exactly what your software is doing. The conformity, you have Azure policy that you can go in and implement policies to make sure that you're conforming to certain features. And changeability, we have rolling DevOps processes that allow you to actually go canary and blue-green deployment quite easily in a multitude of development platforms, DevOps platforms. So we mitigate all of those essential difficulties around software on the cloud. And we do that because we understand we want to grow with the individual, the company, the customer, with their software. And we want to give them a stable platform to help them really and empower their business to achieve more.
Absolutely. That's what Satya tells us when we wake up in the morning and start our days. We're here to empower people to achieve more using Microsoft's different technologies. So there are a number of hosting options for Java on Azure. And I'd like to talk a little bit about those. There's virtual machines. Is that a matter of just grabbing a binary and then eventually, deploying your application?
Yes. So your VMs are very similar to any VM that you would find on any cloud platform. You've got your images that you can get from the Microsoft marketplace, or you can build your own image, and then you snapshot it, and you can have different backups. But at the same time, we partnered with a lot of Java providers for images, certified images that you can actually use to run your Java platform on your VMs. Red Hat, IBM, Oracle, and you can run certified platforms for your WebSphere, WebLogic, JBoss platforms there. And then once you're happy or you want to progress further with your VMs, we actually have the VMs running in a Kubernetes cluster. So if you have a Kubernetes cluster currently that are running WebSphere or Open Liberty or WebLogic, we have certified versions in Kubernetes that will bring up those VMs, add them to a Kubernetes cluster, and then you get that nice orchestration. And it is managed jointly by the vendor and Microsoft. So when you pick up the phone and you say, I need a support request, you'll get that support from the vendor and also Microsoft.
So Microsoft also provides an option for you to work with Jakarta EE images. And could you explain a little bit about what that is and how that also complements these processes of deploying your Java apps?
So Jakarta EE recently moved to the Eclipse Foundation. And what that is, the Jakarta EE, it is a standardized process to develop these libraries that are focused primarily on enterprise integration with your applications. So you would have your front end or your database or your service bus libraries. And these libraries would run in a container. So long ago, containers were the only way to go. And now we're seeing a resurgence to self-hosted systems. So you're running in a WebSphere, a WebLogic, or an Open Liberty container. And you would purchase this container, you would get this container via our workspace, our marketplace, and then you would run it on one of our platforms. And one of the recent platform innovations that we've just partnered with Red Hat is JBoss on app service. So this is a container that is running using Jakarta EE platforms, running on Wildfire or JBoss EAP. And we did some really great engineering, because what that is, it's a heavyweight container that you're running there like a server, but we're running it on app service. So as a result, how does the server actually scale up with auto scaling? Now, what we did is we provided the ability through the Maven build system to be able to publish your scripts, that every time you build up and you bring up another server, it'll actually build up a brand new server every time you scale up. So if you say, listen, I need 2 servers, and are you starting with 1? The second server, when it starts up under load or for on a schedule, we actually go find those nice little scripts that you define and start it up. And then when it's finished, it'll bring it down again. So you get the real power of running those heavyweight servers if you wanted to, without having to really worry about, this is a VM or this is a cluster I have to manage. And we're really got a great offering with JBoss EAP on app service to be able to make your JBoss experience much more painless.
Oh, that's great. That's great. And so I want to ask you one more question before we start taking a look at how this all works together. Why should I consider the Azure Spring Cloud? I know that there's some new offerings that just came out around Azure Spring Cloud. I think something today. We talked a little bit about it before the show. But why would I consider Azure Spring Cloud as opposed to these other options like App Service or VM?
So we're seeing a new resurgence of cloud-based products called Managed Platform as a Service. So in the beginning, you have infrastructure as a service, then you have platform as a service, and then you have software as a service. But in between software as a service and platform as a service, we're now getting something called Managed Platform as a Service, meaning that you have a platform as a service, but it's offering way more. Kubernetes could have been the silver bullet that could have solved everyone's problems. But Kubernetes is hard to maintain and to administrate. It's powerful. The world's computer system seems to run on it. But as a result, it doesn't lend itself to real good velocity, time to market, and ease of developer engagement. So we partnered with VMware, and we created a Kubernetes offering that allows a developer to have an opinionated experience with Kubernetes that is focused on the Spring developer's average life cycle for their app. So, for example, Spring developers understand that they're self-hosted. They have a jar, and they just right-click in that jar and deploy it to a server. They don't have to worry about the control plane for Kubernetes or the underlying infrastructure. They also want to be able to use some of the cloud systems like auto-scaling and distributed tracing, auto-agented, so the agent is just there. They don't have to do any of the configuration without having to set up any Kubernetes configuration. And finally, with those Spring integration starters, they can just they're used to being able to use dependency injection for their libraries. So we've paired that with the Azure Spring Cloud experience to be able to say you can use a library, you can get integration with the Azure systems without having to change that what's the right word? That privilege that you have as a Spring developer of just firing and forgetting and injecting your dependencies as you proceed. So all of the services that you think of and you love with Kubernetes on Azure, we have, and we've just launched today the ability to stop your entire cluster and lower your costs considerably. Let's say you've got a dev test cluster, you just bring it down and you could just bring it up there, carry on with your integration work. And that was just announced today.
Yeah, and I know that there's lots of different ways to monitor Java applications. I know that we just released a new way with App Dynamics to actually do your monitoring for your Spring Boot apps. But we've talked a lot about concepts and ideas, especially about how this all works together with Java and Azure. And I was curious, Rory, if you've got some time to kind of show me some of the things that we've been talking about.
I love live demos. They don't always work. We'll see exactly what we've got, but I have set up some backups there so we can actually go. So okay, so let's go into my screen. So this is the Microsoft version of OpenJDK, which I've already got running on my PC. And I'm going to show you two little tricks that you can get started. First of all, I'm going to go to the Spring Projects Spring Pet Clinic. And I'm going to live code and deploy to Azure a Spring Pet Clinic application. And then I'm going to take the same application and I'm going to deploy it to the Azure Spring Cloud. I'm going to break it up into microservices and show you how you can actually get that in Azure Spring Cloud. So this is the Spring Pet Clinic application. And I've already got this running here, so I can go code. And I can open up in code spaces, or I can actually go into GitHub Desktop. So I'm going to open up into GitHub Desktop. It's going to launch it there. I'm going to go open in Visual Studio Code. And I've already got it running here. And you can see that there's my Visual Studio Code with the Java language pack already installed. And if you want to know how you can check if the Java language pack is already installed, you'll see that it's going to start up an off-process Java language server. You can see there, that's my little Java language server. And that sits on the side. I did a session yesterday and showing you the ins and outs if you want to get it, it's on Dev Radio, that it actually runs a JSON process there that runs the Java 11 JDK. You can see there, it's running the Microsoft version of OpenJDK, and then sends back the JSON as I mouse over there of what I need to do. So this is my Spring Pet Clinic application, and I've got all of these nice little windows here. I've got Java projects. I can go in and inspect all of that. I've got the Spring dashboard. I can just right click on the Spring dashboard, and I'm going to put a little a block there, a breakpoint on the owner service here. I want to show you some real nice new services that we offer as part of the development experience. So let's go find form and let's put a break here. I'm going to go into the Spring Pet Clinic. I'm going to right click in there and I'm going to go debug. Now, what is a code editor? This is a code editor, but it's got a lot of features that you'll get with your normal IDE. Like that Spring window there, you only get that in a production grade IDE because it goes in and inspects all of that Spring code and tells you exactly what's going on with that. So now it started on port 8080. Let me open it up there so I can go into my Spring Pet Clinic there. I can go into localhost port 8080 and I can go find owners, find the owner there. And veterinaries, find owners, find owner, there we go, and edit owner. It should have actually broken there. I'm very curious to why it hasn't broken there. Let's try to add a breakpoint there. And where are we? We're in the owner controller. And it should have actually broken there. But like I said, live demos sometimes work, sometimes don't work. Yeah. Let's go in there. And let's find the owners. But you get the, there we go. It must have just been, and not now. I put it, see, this is the problem with live demos. I put it at the breakpoint there that it wouldn't have actually set the name as null. So now it's broken there. And you can see there, I've got a lot of nice developer experience. You're a Visual Studio Code or a Visual Studio developer. And you'll see there that it's got owner. And I can go in and add a watch there. Owner, and you get that full developer experience there that you can actually go and you can step over if you wanted to, and then you can step return and it's going to bring back all of that. So you get the full debug experience here, but you also get the ability if you wanted to, and you can go into here and you can go in and just right click on your project and you can go deploy to web app. Now, I've already created a little Spring application. I've called it Azure Fun because I was worried a little bit about time. So I'm going to deploy to an existing application, and I've switched on application insights on that application also. So you can see there, I right-clicked there, and I said, oh, let's just go stop there. It doesn't want me to carry it on there. So let's go, oh, yeah, there we go. And it's going to say, okay, cool, you want to deploy to Azure? Yeah, I want to go and I want to deploy. It's going to say to me, where do you want to deploy? Do you want to go create a new app? Or have you got pre-existing config? I think I already did deploy it to that app that I had there, and we'll go check it in here. So it's running the pre-build here, and it's running through the Maven build, and it understands exactly what the Spring developer wants here. And Spring is 60% of most of the apps that we find on Azure right now. So we really want to make the Spring experience for the developer a wondrous experience here. And you've got the Spring Boot dashboard there. You've got the ability to inspect your Spring code here. And there it is. It's deploying to the Azure Fun RP. And it's creating is.
Sorry,
Okay.
you froze for just a moment, but you're back.
I am in South Africa, and you're in New York, though. So and we're using a browser to actually get through this, though. So we're doing a live demo. So we're really,
of course,
kind
something's going to go wrong.
We're ticking the dragon's tail here quite nicely. So it's deploying the app.jar, and I can go into my Azure window here, and it says here deploy to completed. So I can browse the website here, or I can stream the logs. Let's go here. I love how it just pops a Chrome window up where it's not supposed to crop it. There we go. And now I've got my and I've got the pet store application, the same one that we did locally, except I want to see. Okay, cool. It's using a built-in H2 database, and I want to see, is that H2 database, is it performant? And I've got the same demo running with pointing to a MySQL database. So let's see who wins, H2 or a MySQL database that I've got running with Terraform. So I've got some owner information. I just want to add a little bit of telemetry. And I didn't have to change anything. I didn't have to add an agent to any of that Java code. It's just going to trace it out of the box. So now I can go into my Azure portal, portal.azure.com. And I've got my application. I've taken it. I've just popped it onto an Azure app service without any config. It doesn't even know it's running on Azure, that app, right now. There's nothing I changed it to actually run. I didn't even use those Spring integration starter libraries. I just took it from a third-party site, the VMware site, to run here. So now I've got my app here. I've got the Azure Fun RPZA app here. I can see where it's running. I can get some telemetry, but I can also go in and see on application insights, and I can get end-to-end telemetry. I did switch this on. You have to switch it on because it incurs a very small cost, but it is agentless. And I can go into application map. Now I want to see how fast.
There are ways to add lines, like bits of code, infrastructure tooling that allows you to do even more visibility, if I'm right.
Yeah, on the front end, on the JavaScript side also. So you can actually get the browser to say how long the page or a component of the page loaded. I've got a great demo that I do with Azure Spring Cloud that I show Angular all the way down to the database, and you can instrument your Angular page, and then you can see exactly how long Angular took with that. So here's my H2 database, and I can see that it took 36 calls in the last hour, and I can go investigate the performance, and that's that owner's database. If you remember, when I pulled down the owner database here, and I can go into the samples that we get. So we get one sample here. And the H2 database, which is an embedded database, should be lightning fast. So let's go here and let's see how long did it take. And you can see there, it actually took so quick. It took 16 milliseconds, and it's getting the owner here, and it's retrieving all of the owner's details. So it's very performant, and it's even doing a count, an aggregate call there on the database. So let's see how long this took on our MySQL database, and then we can actually make a decision. Do we want to use MySQL? Do we want to use H2? Or do we want to actually increase our auto scaling for our server? Because it might be that the server itself is taking too long. You can see that it's taking 62 milliseconds for that find form, but the actual REST call is taking 133 seconds, which means the database is not the slowest part of that entire call. So let's go into our application. Let's go into our app services, and I've called this Terraform RPZA. And what this is, it's the exact same application, the Spring application. I can even prove it to you here. Except the difference is I've actually gone into the configuration and I've added a MySQL URL in the app configuration. And I've deployed it also via the Java Learn path. You can actually learn how to deploy it with Terraform. So in the configuration, you can actually go in and you just, like a .NET app or a JavaScript app, you can go in there and you can just set the URL, the database username and password to your MySQL instance. It's not ideal. You shouldn't actually do that. You should use a key vault. We're really trying to encourage people to use zero trust principles, when one of the cornerstones of Zero Trust is don't put your passwords anywhere. Have a multi-factor authentication device, and you rather use that. And here's you can see there the URL, the username, and it is going to, if you go into the URL here, it's actually pointing to a MySQL instance. So let's see how fast that is now. So I've got my application here, and it's pointing to my MySQL database, the exact same application that I have here. And you can see here T-form. This is the application, and I can get find. It's a little bit fast. It feels a little bit faster here, and I can update that owner there, and I've created some telemetry before that. But let's go see on the application insights. And then once that's done, because we're using a MySQL database, I can actually create multiple instances of this. Now, the H2 in-memory database, I can't do that because that's one app pointing to something in memory. But with my MySQL database that's sitting outside my app, I can go in and I'm going to show you, I'm going to scale up live on air to 2 instances and see if we actually get some better performance here. So I can go view application insights, and let's see how quick that. Now, this is only a 2 CPU instance of MySQL. You can get up to multi-CPU. I think it's up to 64 instances that you can get there. So let's see what our performance is here. And then you can make your decision. Remember when I said to you with those essential difficulties about software, the conformity, the changeability, the invisibility, and the complexity. Let's go here and let's see exactly, can we see if our database or if our REST service is more performant. So get owners is 73 milliseconds, and I can go all the way through to my samples here. There's my one sample that we got. This demo is going really good. I'm glad nothing broke just yet.
I'm loving it.
And look at that. And we get really fast performance here. We get a lightning fast performance. But not only that, but the MySQL database is really connected and responding well to our REST call here. You can see the REST call here, get owners, 73 milliseconds. And the database, the rendering there is very fast. Because MySQL and Azure MySQL is really optimized for your database. It understands and is really performant here. So now I want to just get a little bit more performance with that database and with my REST calls. So I can go into my application. Now, because it's sharing a database, I can go scale out. And exactly like you would with your .NET or your JavaScript applications, I can just go either custom auto scale and on Tomcat session counts if I want to do, or I can just go to services here and it's going to scale. It's not going to drop the connection at any given time, and I'm going to get better performance for that. So that's your app services, but I can take the exact same app and I can chuck it onto Azure Spring Cloud, and the customer, the vet service, and the visit service now becomes individual microservices. I can go to Azure Spring Cloud, and I have deployed it, and this is in the monitoring module. If you go into the Java Learn path, right at the bottom of the Java Learn path, there's a monitoring module, and it scripts out your entire ecosystem and your Azure Spring Cloud instance here. And you've got your apps call, but I just want to highlight there that we've just launched that today. You can stop your entire cluster, and then you don't incur any, you incur a very small cost, but not a great cost like running your Kubernetes instance here. So you can go into apps now. Now, my app itself, you can see there, it's got a admin server, an API gateway, a customer service, a vet service, a visit service, but I can scale out each one of my individual services. So customer service here will return back all of my my customer objects. And you can see here, I've actually set it up beforehand, and I've set up my customer service to go in and increase the count by 1 when the Tomcat instances, so the web server instances, are greater than a certain amount, and then to scale down and to do a lot of cost cutting when it is kind of stopped, that load is. And this is great for Black Friday. You think about it. Each one of those individual Spring microservices now can scale up. And I didn't have to really worry about Kubernetes. It is Kubernetes underneath there, but I can just take that exact same app like I showed you before. And if I wanted to break it up into microservice, if not, I can just chuck it onto Azure Spring Cloud and then deploy it there. And I get the benefits of Kubernetes without having to worry about the control plane. Now,
you're not messing with pods. You're not creating containers. All you're really doing is deploying the code. And I know that there are CI/CD solutions to do that, to also add that automation process so you can just push and then have it automatically start a deploy.
So you can see here, I did do a live test earlier today, and I put some load on it. I actually sent it a couple of 100,000 transactions, and it scaled up. And as soon as it actually scaled, it realized the load was lost. It scaled down. Now, what this means is that you can take, and we're seeing a resurgence of this new cloud mindset of cost savings, because instead of actually saying how much do I need and doing that broad forecast of 3 years and then adding a fudge factor of 20% onto it, like normal CTOs would do, we're saying how much can we lower the cost to. So instead of going, okay, Black Friday, we can always get more scale. The cloud's there, and we're here to empower our customers. But we're also saying to our customers, we can save you money by actually scaling down to the lowest cost there. And as soon as you need it, it's still there for you when you want it.
Yeah, and utilizing metrics. So you can, we always like to use the term data-driven when it comes to making decisions. But you'll actually get real-time data on performance, so you can set particular metrics on why you would want to scale up and when it's time to scale down. And what I really like about this is that we're not managing our load balancer pooling on our own either. We're allowing this to kind of add instances into the load balancer and remove them without us having to do some manual intervention.
Oh, this will make you will sleep well at night with this. And I know that because one of our customers uses this to sell apples. Kroger, which is one of your largest supermarket chains, every time you buy an apple from Kroger and you go scan it at the till set, it actually runs Azure Spring Cloud and says, do I have enough apples? And if it doesn't, it will go in and set an inventory request to one of the 3,000 stores and scale up there. So Kroger is a great example of how we run on Azure Spring Cloud and how their developers really have a great experience in deploying. They just deploy, and they don't have to worry about the control plane, the Kubernetes scheduler, the etcd, any of those features, because they're just developers. They want to create and have that development experience.
Super important. We want to empower our developers to be able to do more. That's one of the big things that we need to consider, is that how developers are able to act with self-service, create the actual infrastructure they need without having to work with another person in that process. And while we don't want to say that people who are in ops roles are irrelevant, that's not the case, because they're still looking at telemetry, coming up with rules, checking observability to make sure that we're at our best performance. We're creating monitoring solutions. So we've got about 12 minutes left, and I'm going to let you kind of take it from here on what's next.
So I love what you said about, the DevOps and the ops admins are still important more than ever, because as part of Zero Trust, you want to take that Azure Spring Cloud instance and you want to actually segment it into Zero Trust subnets and hub and spoke virtual networks. So you can see here, this is one of our reference architectures, and we have the firewall, the gateway subnet, the app gateway, and the centralized services subnet, and that's in the hub virtual network, all fronted by a web gateway. And then you've got a VNet link through to your services runtime that is going to run your config server, your service registry for your microservices. And then your developers, the only thing that they really have access to is your Azure Spring Cloud deployment app subnet. And then you've got your data services subnet also, though. So more importantly than ever is the ability to have Zero Trust and be able to segment your systems and optimize your systems according to the on-premise interactions, the ingress and the egress, and the ability to actually say, wow, that app shouldn't be there, or that individual shouldn't have access to the centralized services subnet. And it's a great reference architecture. You can get this in our architecture center. And this is our Zero Trust secure apps with managed virtual networks. So I've got a lot of nice homework that you can actually take on for that. So the first thing that we can do is go in that Java learn path.
Sure.
You can go, I'm going to go right down to the bottom and get those nice links there. Let's go there. PowerPoint is really taking some strain here. I'm zipping through with my magic mouse as fast as I can, and this thing is hard to scroll because you just kind of like, just scroll on the top of it, there, and you just hope that the finger makes the glass work. So the first thing I want to ask you is, do you like learning? Do you like, free learning opportunities? And now I'm a content writer, so I've taken a lot of the concepts that I've shown you today, and we put it, myself and the Java team, into Java-Learn-Path. And there's 16 modules there, and they're made to be bite-sized. Most of them you can do at lunchtime, and you'll come out of that with outcomes of, I understand the service, Redis Cache, Azure Spring Cloud, App Service, Jakarta EE with that Java Learn Path. The other one is, how do I migrate? How do I take an existing platform or service, like an old JBoss app, and pop it onto JBoss EAP, or an old WebLogic app and pop it onto App Service? And that is the Java migration portal. So the Java-migrate. And everything that you can think of how do I move to the cloud is there, including the migration services that you can download a PowerShell script. It will scan your Tomcat instances, create a Kubernetes cluster, or move it to the Tomcat service on App Service there. And that is the one-click app migration wizard that you can actually get with the migration tooling. And that's Java-migrate. And finally, we mentioned a lot of nice big buzzwords. I mentioned microservices and Spring Cloud and Kubernetes clusters and everything. And all of these would be great if like everyone knew everything about that. But software, like I said, is complex. So wouldn't it be nice if we had an architectural portal to do that? And this is one of the things I fell in love with Microsoft so long ago, the architectural guide. And this is a portal, a platform that you can get all of the insights into all of the little nuanced buzzwords that we've used today. And it allows you to actually go, wow, am I using best practice? What is a circuit breaker platform pattern? And how do I use that? And it's defined in the architecture guide there. So you can see that's the screen there, and you can go into design patterns. And I go in there sometimes for light reading. I want to go read up a design pattern, and I can go into, let's go in, and I want to show you one of my favorite design patterns that I recently found. And okay, so here we have, and you've got not architecture styles, design principles, and then you've got best practices. And I want to go into, there we go, the design patterns. So you can see here, there's so many nice patterns. Bulkhead is one of the best ones. The bulkhead pattern is a type of application design that is tolerant of failure. So one of the things that we've been recently doing is creating, and we just created Chaos Studio. And and Chaos Studio is based on the Bulkhead platform. It is tolerant of failure. So you can create the Chaos Studio, and this will actually show you how to create tolerant, resistant applications. And in one of the samples that I've given you, the monitoring sample, we actually use Chaos Monkey to go in, and when we deploy our application, to go in and go and test all of those services, to bring them down, to break those services and see, are they resilient in how they are deployed and are accessed. So you really want to go to.
There's also Chaos Mesh to actually work with your Kubernetes. That there's and different containers. There's so many new options, and it's really cool because I saw kind of watch chaos engineering itself kind of grow, and I've seen vendors that created complementary products. But it's nice to see that Azure brought its own into this so that you can natively do your chaos experiments within the portal.
We are going to outsource all of the pain that developers and infrastructure professionals have ever felt to cloud-based services. You think about it, the testing and the manual pen testing that we used to outsource and it was painful. We're actually now doing via platforms and making it not only really cost-effective, but easy to understand. You've got now a studio that allows you to define all of your failures and your bulkhead patterns, and then just instinctively go in and see, where's my success? Now, with Azure Spring Cloud, you can have that failover, that instant failover. You can also have canary deployments that allow you to have deployment slots. And then you can have the cluster tell you, wait a second, is my node healthy? If not, with availability. And then you can bring up your different nodes there, your different microservices based on availability checks. So everything is done for you. So all you really need to do is have an idea to production. That's really what you want at the end of the day. You want time to market, and you want to be able to not worry about those essential difficulties that Brooks actually mentioned in the seminal paper, No Silver Bullet, because software is now becoming smart. It's really helping us create wondrous experiences for Java developers.
Absolutely agree. So we're coming down to the end of it. And I know that there's this really cool little framework that one of our members of our org, Julian, had spent time on. That's open source. If you want to start taking a look at how to build and deploy one of your very first Java apps, I really recommend checking out jhipster.tech. Jhipster will really help kind of kickstart your process. I really think with all the framework generators there are out there, jhipster really helps people get started. But we're just about out of time, Rory, and I wanted to ask, is there any interesting things that you're going to be releasing, or any new talks that you're planning, or any place that we can go to see Rory tomorrow or the day after that?
Well, first of all, hashtag follow me on Twitter on at Rory Pretty. And I do memes, I do Azure updates, I do a lot of advocacy for Microsoft based on two real concepts, Java and accessibility. So you had me here previously on accessibility, and I showed you live demos in Java and other languages also on how you can actually program, but you can also think, wait a second, how do I check with accessibility? Now, one of those things is that you can use accessibility insights, and that is accessibilityinsights.io, https accessibilityinsights.io. And that is a tool that I use every day, that Java Learn Path. I actually checked with accessibility when I created it with the same tools that Microsoft uses, that is baked into Microsoft Office, that is baked into an Azure even, to drive accessibility. So yeah, definitely follow me on Twitter and get the badge for Java on Azure Learning Path, and then tweet me and connect with me around the experiences that you had. Because my role as a developer advocate is to meet developers where they are, and to also to feed back to the product teams to say, let's make that experience wondrous.
Absolutely. So Rory, thank you so much for being part, and also for your last time you were here, you taught me so much more about accessibility than I thought I already knew. You've today given me a lot more to kind of think about when it comes to how Java applications can be deployed on Azure, what I can use, how I can use it, and how I can actually learn more about working with all these interesting technologies. So Rory, I really appreciate your time. And I know it's a little late over there in Johannesburg, and I want you to go enjoy the rest of your evening and eventually your weekend. So thank you very much.
Thanks, Jay. It's always a great and always a pleasure. And I'm glad all my demos worked today, because it's like going off script with you, but everything was kind of semi-prepared in beforehand. We did some live coding demos there. We deployed multiple applications. I showed you Azure Spring Cloud. Thank you so much, Jay. And it's like New York. Johannesburg doesn't sleep all the time also, though. We're very similar in that way. The only difference is I've got some plants that you have to spruce that area up. They just get a little bit of a plant. But I warn you, that one over there, that is the difficult one. It doesn't talk to me. There we go. It doesn't talk to me, but it has to go near the freaking window there, because else it starts to complain. And that one over there, that one there doesn't complain. It's like a pet. It's like I don't need all of this nonsense with these children. I've got children and pets and fish, and I don't need plants there that are so opinionated. So get a plant, but make sure that it likes your apartment.
Well, I'll consider that. Anyway, let's give everybody the good big wave goodbye. We'll see you next time. I'll catch you all after the Thanksgiving holiday. Until then, this is Jay. Thank you, Rory. We'll see you next time.